Okay, this is Math Studies, Lesson 8.4. We're going to continue working with exponential equations. We're just going to have a little twist with the ratio. So we're still working with our y equals a times b to the power of x, where a is our starting value, our intercept or zero value, and b is our ratio. But rather than doing what we did yesterday, which was dividing consecutive terms to get the ratio, we're going to be working with percentages, percent change. So now to get the ratio, if you are in an increasing situation, you take 1 plus whatever percentage you're given as a decimal. If you are in a decreasing situation, you would do 1 minus whatever your percent is as a decimal. So for example, if I had a 12% increase, I would do 1 plus 0.12, and that is 1.12. So the 1 plus represents 100%. If I have 100% of something, and I'm going to add 12% to it, I'm left with 112%. A percent decrease example, let's say I have an 8% decrease, 1 minus 8%, and 8% is 0.08, we move that decimal 2 times. That's going to give me 0.92. And so the idea is if I had 100% and I take away 8%, I'm left with 92%. So these values are the values that would replace our ratio in our exponential equations. Otherwise, we're going to keep doing the exact thing we did in lesson 8.3. So, example A says Seth deposits $200 in a savings account. The account earns 5% annual interest. Assuming that he makes no more deposits and no withdrawals, calculate his new balance after 10 years. So we're starting with $200, and he's earning 5%. So my ratio is going to be 1 plus 5%, 1.05. After 10 years, how much does he have? So we have my starting value, we have my ratio, and then to the power of 10 to show 10 years. Gives me $325.78. Yeah, that was right. Okay, example B says half-life is the amount of time it takes an element to decompose to half its current state. The half-life of carbon is 5,730 years. If Karen has a 30-gram sample of carbon, how much will be left after 6 half-lives? So we are starting with 30 grams of carbon, and a half-life means that we have 100% of the item, and we're losing 50% of it, half of it. So after 6 half-lives, how much is left? And less than half a gram would be left over, so I'll do 0.47. Example C says the current population of Cityville is 217,000. The population has been decreasing at a rate of 16% each year. So I have I'm going to write my equation up here, since I got a part A and a part B. I have my starting value, and I'm losing 16%. Means I'm maintaining 84%. If I have 100% and I take away 16%, I'm left with 84%. What's the population after 4 years? So we got my 217K, we got my 84, and we have 4 years. And that means after 4 years, I only have 108,000 instead of my 217,000. That's almost half. That is half. 108 0.038. What was the population 6 years ago? So, this one's kind of weird. If we're going to go back in time, what we're going to do is we're going to undo reducing. We're not going to change the percentage to increase 16%. We're going to undecrease. To undecrease, we're going to use a negative exponent. So do not use a 1.16 for the ratio. We're going to keep with our 0.84, but to go back in time, we use a negative exponent. So, 6 years ago, we had over 500,000 people. We had 617,000. Okay, that's it for the notes for 8.4. Good luck on the exercises, and please let me know if you have any questions.